The kernel and the nullity of linear transformation using these two matrices here can be defined using the type of matrices here. This is a 3 by 2 matrix. This is also a 3 by 2 matrix. And the kernel allows us to form a set of all vectors V that will satisfy a transformation where the result would be the 0 vector itself. But to do that, let's try to pattern this into m by n so that we would know the type of 0 vector and the vectors or the elements of kernel T, with the vectors of the element of kernel T that we are going to use. The transformation for our here defined by the matrix, we have here r to the n to r to the m. Our n is 2, so we have r2 to r3. In short, the 3 here describes the 0 vector. So our 0 vector is an element of R3, so we have 0, 0, and 0. This R2 here will describe the vector and the set of all vectors we are going to solve. Since it's R2, we can have V sub 1 and V sub 2 here. Because that's what we're going to use in this manner. We have a transformation of vector V is A times set V equal to 0 vector. Again, the 0 vector is an R3 and this V vector would be in R2. To start, let's come up with the reduced row echelon form of this matrix. So we have here 1, 2, negative 1, 0, 1, and 1. Of course, you could even stop at row echelon form, but just for the purpose of this discussion, let's come up with the reduced row echelon form of this matrix. The first thing here is to add row 1 and row 2, place the results to row 2 to make this 0. Next, multiply negative 1 to row 1 plus row 3, make it a new row 3 to make this 0. So we have here 1 and 2 as well. 1 plus negative 1, 0. 2 plus 0 is 2. We'll have negative times 1 is negative 1 plus this, that's another 0. Negative 1 times 2 is negative 2 plus 1 is negative 1. Then let's make this leading 1 by multiplying 1/2 to row 2. So we'll have 1, 2, 0, 1, 0, and negative 1 here. Finally, to make this 0, let's add row 2 and row 3. Okay, for a new row 3. And we could also target this 0 because our goal is a reduced row echelon form. At once, we can multiply negative 2 to R2 plus R1 for a new row 1. 1, 0, 0, so we have 1 here. 1 plus negative 1 is 0. Negative 2 times 1 is negative 2 plus 2, 0 here as well. This is now the reduced row echelon form of our matrix. And with this, we will now use this here. We are going to multiply this with a certain vector, but more specifically in R2, V sub 1 and V sub 2. How would we know that it's really correct? When you look at the product, we have 2 and 2 here, it's defined. Because once you made a mistake here in saying there is a V sub 3 here, and if we're going to add here V sub 3, the product is no longer defined since we only have 2 components here. Okay? So I already removed V sub 3 there. This is equal to our 0 vector in R3, 0, 0, and 0. But of course, when you multiply that, V sub 1 is 0, V sub 2 is also 0. No more, no less. These are the components of your vector which can satisfy this. Okay? So our vector here can have 0 and 0, or the 0 vector itself. Now, a 0 vector in R2 itself. So the kernel of T will contain the 0 vector in R2. Okay, as kernel of T contains vectors V such that, again, the result, or it is mapped to 0, 0. The nullity of T is equal to the dimension of the basis of your kernel. In short, the nullity of T here is not 1 because the dimension of the basis of the kernel doesn't count the zero vector itself. Doesn't have basis. So we have here 0 as our nullity of t. This only happens again if your kernel of t contains zero vector itself. Let's see if it's the same thing with the same situation here. So we will have the reduced row echelon form this 1, 1, 0, negative 1, 2, and 1. This is already 0. So what we need to do here is to multiply negative 2 to row 1 plus row 3 to have a new row 3. So that's 1, 1, 0, negative 1 here as well. Negative 2 times 1 is negative 2 plus 2, 0. Negative 2 times 1 is negative 2 plus 1, negative 1. Okay? So let's make this, let's multiply negative to row 2. So 1, 1, 0, that's positive 1, 0, and negative 1 here. And to make this reduced row echelon form, this should be 0, this should be 0 as well. What we can do first is to add row 2 to row 3 to make the entry in row 3 0, and then multiply negative 1 to R2 plus R1 so that this would become 0 as well. So we have 1, 0, 0, the middle is 1. 1 plus negative 1 is 0. Negative 1 times 1 is negative 1 plus 1, 0 as well. So it actually the same as the previous. Multiply with our vector in R2, equate in our 0 vector in R3. V sub 1 is 0. V sub 2 is also 0. The same here. The vector, its component is 0 and 0. However, the kernel of t is just the set containing 0 and 0, while the nullity of t, as mentioned, if the kernel of t is containing the 0 vector itself, we have here 0. So the nullity of t, the kernel of t is here. So they have the same results for the two given matrices here. The concepts included the transformation of a matrix into its equivalent reduced row echelon form. And again, this is very important because this declares the type of vector v and the 0 vector that we are going to use in our processes. So always start with this, and since they are the same 3 by 2 matrices, we have this form. Thank you very much for watching.